Welcome to another session. So today I want us to talk about the reduction formulae from a trigonometry. So before we talk about that, we have to know how to define our trigonometric ratios. We normally use three trigonometric ratios. Namely, we have the sine of theta, and then we also have the cosine of theta, and then we also have the tangent or the tan of theta. So when we define this, we say sine is equals to the opposite side divided by the hypotenuse side. Then now our cosine is equals to the adjacent side divided by the hypotenuse side. Then now our tangent is equals to the opposite side divided by the adjacent side. So this is what we call SOHCAHTOA. This is SOHCAHTOA. So these are the definitions of our trigonometric ratios. So if we have a right angle triangle, and then we put our reference angle here, which is theta. So this side, which is opposite to this angle, we call it the opposite side. And then now this side here, which is here, we call it the adjacent side. It's adjacent to our reference angle here. And then now the longest side, we call it the hypotenuse side. So this is how we can define our three trigonometric ratios. So if we put this on a Cartesian plane, we're going to have our theta here, and then now these are our x-axis, then going up, these are our y-axis, and then now this is our r, our radius. So in this case, we can define sine theta. Okay, this is a 90-degree angle. So this is our y, because this is parallel to the y-axis. So we can define this as opposite over hypotenuse. So the opposite side here is y over our hypotenuse side, it's r. And then now we can define our cos of theta to be the adjacent, which is this side here, which is x, over our hypotenuse side, it's r. And then now our last trigonometric ratio, which is tan theta, we can define it as opposite. The opposite side is y over our adjacent side, which is x. So this is how you can define your trigonometric ratios on a Cartesian plane. So when we talk about the reduction formulae, we are going to use what we call the cast diagram. So from our cast diagram, we are going to have something like this. This is our cast diagram. All right. So we start here at 0 degrees, and then now here we're having 90 degrees, then 180 degrees, then here it's 270, then we end up here at 360 degrees. So how do we explain this? So this means that here in the first quadrant, where you see capital letter A, it means that all the trigonometric ratios are positive here. So it means sine is positive in this quadrant, cos is positive, also tangent it's positive, for as long as the angle is less than 90 degrees. Between 0 and 90 degrees, then all our trigonometric ratios are positive. And then now we move to the second quadrant from 90 degrees to 180. So we see S here. So it means that only sine is positive in this quadrant. Only the sine is positive. Then it means the other two trig ratios are negative. And then when we go to the third quadrant, which is between 180 degrees to 270. That is where the only trigonometric ratio that is positive, that is our tangent. Only tan is positive in this quadrant. Here it's only sine which is positive. And then between 270 and 360 degrees, that is where we see letter C, whereby it tells us that cos is positive in this quadrant. All right, so how do we really redact when we are having our cast diagram? So when we are having our cast diagram, in this first quadrant between 0 degrees and 90 degrees, that is where we are going to have maybe something like this. We're going to have our reference angle there as theta. Then this theta, it has to be 90 degrees minus theta, because theta lies between 0 and 90. So it must never be equals to 90, but theta must be between 0 and 90. So that is where we are going to have something like this. For the first quadrant, we have 90 degrees minus theta. That is the restriction there. So when we have our trig ratios, we have sine of 90 degrees minus theta, and then we also have cos of 90 degrees minus theta, and then we also have our tan of 90 degrees minus theta. All right, so these are our three trigonometric ratios in the first quadrant. Okay, so now we'll come back to the reduction part. Then let's go to the second quadrant, whereby we have an angle which is between 90 degrees and 180. So if we have an angle here, it will be around here, which you can see that this angle is relative to this line here. So it means this angle here will be 180 degrees minus theta. That is the restriction there. That is the second quadrant, which is 180 degrees minus theta. So it means that our trig ratios will be sine of 180 degrees minus theta. Then we will know that it's equals to something there. Then we also have the cos of 180 degrees minus theta. Then our tan of 180 degrees minus theta, just like that. So this is the second quadrant. Then when we move to the third quadrant, we are going to have our angle here. So this angle will be 180 degrees plus theta, because this angle is relative to this line here. So in this case, it's 180 degrees plus theta. That is the third quadrant. So the third quadrant is 180 degrees plus our reference angle. So it means we are going to have sine of 180 degrees plus theta, and then we have the cos of 180 degrees plus theta, and then now we have our tan of 180 degrees plus theta. And then now when we go to the fourth quadrant, we are going to have a triangle like this. Then our angle will be there. So you can see that this angle is relative to this line here. So this one will be 360 degrees minus theta. All right, so for the fourth quadrant, let me write it here. It's 360 degrees minus theta, which is our reference angle. So now we're going to have sine of 360 degrees minus theta, the cos of 360 degrees minus theta, and then this is tan of 360 degrees minus theta, just like that. So now we need to reduct. Then what is to reduct? When we reduct, we look at the reference angle in our trigonometric ratios there and then make a judgment out of them. So here, when we look at this, remember this is for A, which is for all trigonometric ratios to be positive, and then now this is for S, then this is T, and then now this is C. What this tells us that here on the second quadrant, only sign is positive if we have an angle like this. If we have an angle like 180 degrees minus theta, then that is where only the sign of that reference angle will be positive. So if we have sine of 180 degrees minus theta, then when we reduct it, we're going to have sine of the angle. And then now when we have cos of 180 degrees minus theta, we're going to have negative cos of theta. Then here we're going to have negative tan of theta. So here it means only the sign is positive in the second quadrant. Where you see 180 degrees minus theta, then that is where you know that sign is positive. Then all the other trigonometric ratios are negative. Then when we go to 180 degrees plus theta, we know that only tan is positive. Then it means here, when we get here, we have sine, then it will be negative sine of theta. Then now here we're going to have negative cos of theta, but we know that when it's 180 degrees plus theta, that is where our tangent is positive. We're going to have tan of theta. Then now we go to the fourth quadrant, which is this one with C. 360 degrees minus theta, this is our reference angle. So when you see this, you know that only cos is positive. Then it means that the sine and the tangent will be negative. So we are going to have negative sine of theta, and then now this will be positive cos theta, then now negative tan of theta. All right. So when you work with this reduction formula along the horizontal line, the trigonometric ratios will stay the same. They will only change their signs to positive or negative. But when we work along the line, the y-axis line, this vertical line here, the trigonometric ratios changes to what we call their core function. So if we check this one, we have the sine of 90 degrees minus theta. Then that is where we know that in the first quadrant they are all positive, ne? So every answer where you see 90 degrees minus theta, it should be a positive answer, because that is according to our cast diagram. All right, so here, because we are working on the line, on the vertical line, these trigonometric ratios will change to their core ratios. So sine will change to its core ratio, with its cos, and then cos will change to its core ratio, which is sine, and then tan will change to what we call the core tangent. So now when you have 90 degrees minus theta, then it will change to cos of theta. And then when you have cos of theta minus 90 degrees, still falls in the first quadrant, which is positive. Then we're going to have sine of theta. And then now when you have the tangent, it will change to cot of theta. All right. So the tricky part about this line, the vertical line, is because you can reduct, but if you forget to change the trig ratios to their core functions, then you'll have a problem. Okay. Also, you can see that here our angle is 180 degrees minus theta, or it can be 90 degrees plus theta, because anything more than 90, then it falls in this quadrant. So what if we have the sine of 90 degrees plus theta? All right, so we check on sine. We know that sine is positive in this quadrant. All right, so we are going to have a positive answer. But what is the co-ratio of this? Then it will change to cos of theta. Then now if we have the cos of 90 degrees plus theta, then we know that cos is negative in the second quadrant. Then we're going to have negative. Then the co-ratio of cos, we know that that is sine. And then our angle is theta here. Then similarly, if we have the tangent of 90 degrees plus theta, then we know that tan is negative in the second quadrant. Then now this changes to what? The co-ratio of tan is cot, and then we have our reference angle, which is theta there. All right, so this is how we deal with the ones on the vertical line or on the y-axis line. Similarly, if you use 270, which we are going to, we can have 270 degrees minus theta, or 270 degrees plus theta, because it's still on the same horizontal, on the same vertical line. Okay, so if we have the sine of 270 degrees minus theta, then we're going to look at this quadrant here, because 270 degrees minus theta, it means the angle falls within this interval here. So it means that we look at sine here, we know that sine is negative, so we should expect a negative answer here. We're going to have a negative, and then the core function of this, the core function of sine, we know that is cos, then we're going to have negative cos of theta. Then if we have cos of 270 degrees minus theta, then we know that in the third quadrant, which is this quadrant here, it's only tan which is positive. Then we're going to expect a negative answer, and then now the co-ratio, it will be sine of theta. Then if we have the tangent of 270 degrees minus theta, then tan is positive in the third quadrant, then we're going to have the co-ratio of it, which is cotangent of theta. Then similarly, if we have 270 degrees plus theta, which is our reference angle here, then the sine of 270 degrees plus theta, then it means this is 270, this is 360 degrees. 270 plus theta, it falls within this interval here, which is the fourth quadrant. Then now sine is negative in the fourth quadrant, but it will change to its co-ratio because we are working relative to the vertical line. Then it will be negative, and then the co-ratio of it will be cos of theta. Then if we have cos of 270 degrees plus theta, we know that cos is positive in the fourth quadrant. Then we're going to have a positive answer, but what is the co-ratio of cos is sine. Then we're going to have our theta there. Then if we have our tangent of 270 degrees plus theta, then this will be equivalent to, we know that tan is negative in the fourth quadrant, and then now we're going to have the co-ratio of it, which is cot, and then we're going to have our theta there. So basically, this is our reduction formula. This is how we use the cast diagram to reduct. So our cast diagram says all station to Cape Town. So it means only cos is positive here. then all the trigonometric ratios are positive here. Only sine is positive, and then this side only tan is positive. And to best work this, you should use your angle relative to this line here, because it makes things simple. The only thing that will change it will be the sine. So if you use 90 degrees minus theta or 90 degrees plus theta, you should not forget about what we call our core ratios. It's very important. But if you use 180 degrees minus theta, then 180 degrees plus theta, and then we also have 360 degrees minus theta. Also here it can be 360 degrees plus theta. So when you have these reference angles, then I believe it can be simple to reduct. So without a waste of time, I want us to check our first example on how to simplify these equations using the reduction formulae. So we're given this to simplify this expression here. So we're given the cos of 360 degrees minus x. It means our x is our reference angle. And then multiply by the sine of 360 minus x, multiply by cos of 90 degrees minus x, all divided by sine squared of 90 degrees minus x, multiply by this sine of 180 degrees plus x. So we have to use the reduction formula in order to solve this. Okay, so we can have our cast diagram here. All right, remember how our Cartesian plane is. So if we have 360 degrees minus, it means it's in this quadrant here. So cos is positive here. So it means when we reduct this, it's going to be positive cos of x. Then we multiply that by the sine of 360 degrees minus. We can see that 360 minus, it's here, because this is 360 degrees. Our angle is in this quadrant. So in this quadrant is only cos that is positive. Then it means we're going to have minus sine of x. And then now we have cos of 90 degrees minus. So this is our 90 degrees here minus, then it means this is the first quadrant. So remember, when you have 90 degrees or 270, then the trig ratios changes to their core ratios. Then now it means you're going to have this trig ratio to change. Okay, because these are in the first quadrant, all the trigonometric ratios are positive. Then we're going to have positive, and then this changes to sine of x. Then now all divided by, then now we work on the denominator here. So still we're in the first quadrant, 90 degrees minus x. So it means this trigonometric ratio will change to its core ratio, which is cos, and then don't forget that squared here. Then our reference angle is x. So now we deal with this one, sine of 180 degrees plus. So this is 180 degrees minus, then this is 180 degrees plus. So it means 180 degrees plus is in the third quadrant, and we only know that tan is positive there. So it means we are going to multiply this by negative sine of x. Then now we can work this out, because there is no addition here. We're only working with multiplication and division. Then this term can divide this term here. Then now we remain with cos of x multiplied by sine of x divided by cos squared x, which is the same as cos of x multiplied by cos x. Then now this one will divide this one. Now we remain with what? We remain with sine theta or sine x divided by cos of x. And then we know that this is what we call an identity. So when we have sine of x divided by cos of x, then now this will give us tan of of x. Then now we have simplified our expression using the reduction formulae. So this is how we can solve this kind of expression if we're given this kind of expressions.